Hello, everyone, and welcome to the Road to the Metaverse Creator Series. In today's session, we're going to learn to create a guided maintenance experience for HoloLens using the Microsoft Mixed Reality Toolkit. My name is Drew Demokis, and I'll be your MC for the session. I joined Unity back in 2020 as a creator and developer advocate, focused on showing businesses how AR and VR can solve problems and modernize old processes. Now, let's meet our hosts, starting with Jerome.
Hello, everyone. I'm Jerome, and I've joined Unity back in 2018. And prior to that, I spent about a decade using Unity for production in agency work for anything from installation to XR to even working with embedded devices like in-flight entertainment systems on airplanes. And today we are joined also by Vanessa.
Hello, I'm Vanessa, and I've been at Unity for roughly 5 months. And my background is in computer game development, and I'm here to support the Road to the Metaverse series. Welcome all.
Thank you. And Ben is not here today. He's on well-deserved vacation for the end of the year. We're assuming he's skiing in the Alps, dressed as Santa. That's not necessarily the case, but that's what we chose to believe.
Assuming.
All right. Thanks, guys. Okay, so as everybody can see, we have today's agenda on display here. So following a quick introduction, very quick today, we'll dive into today's main topic. So before we get started, if you have any questions at all during the session, please type them into the Q&A pod on Zoom. The session will also be recorded, and an on-demand version of the webinar will be made available sometime early in the new year. As always, we're really looking to hear from you about how we can improve our presentation. So I also have a survey available at the QR code on screen and link that I'll post in the chat just now. So please fill that out when you get a chance. Now, before we begin, just like to shout out a few helpful links where you can learn more about Metaverse content, starting with our Metaverse Minute blog. There's a great number of stories to be found on this blog, a lot of which I've actually featured throughout our series. So feel free to check that out. And again, I'll be posting links in the chat as we go. Our Road to the Metaverse forums, if you haven't already checked them out, we have a dedicated forum for this series. So you can check them out at, again, link and QR code. So you can keep the conversation going following today's session and over the holidays as well. And one last shout out to the Road to the Metaverse Executive Series. This is kind of our sister series where Ryan Peterson, Unity's VP of Professional Services, is joined by special guests, and they tackle the how and why behind this new era of consumer and social experience. These chats are designed to spark imaginations, and they end with live Q&A. There's currently 5 episodes on demand at the link and QR code, once again, on screen here. And there's a new session coming up January 24th, so please check those out as well when you have the chance. But yeah, very quick introduction today. With that, I'd like to hand things over to Jerome and Vanessa to get things started.
Thank you, Drew. Yeah, that session about UGS looks like it's going to be really fun. All right. And I shall grab the screen share. And there we go. You should see my slide, which is identical to Drew's. So before we start, actually, as I mentioned in the chat, this is the last workshop for the year. Don't worry, there's still a few more. At the beginning of the year in the series, we have after today we have 3 more episodes that we are going to work on, but we have delivered so far 9 episodes, and I wanted to spend a second just recapping for those of you who joined us maybe later in the series or are joining for the first time today. There's a whole bunch of content available on the Road to the Metaverse landing page, which Drew shared with you earlier, and starting from obviously the introduction series, but bringing assets right into Unity in order to work with your data sets, whether it's importing physical assets inside or digitizing them to take them inside Unity, or converting digital assets like CAD or BIM data. Adding interactivity, this was our first deep dive into visual scripting. So the whole series is based on visual scripting. Again, how to bring real-time 3D data into your digital twin. I was looking at how to ingest REST APIs, but also how to ingest, for example, weather data. Again, we looked at introduction to VR or XR, let's say, VR, AR, and all the Rs, as we said during the episode, augmented reality, and VR with building immersive worlds, again, VR with immersive training. And today we are looking at building a HoloLens experience for training in AR. So As highlighted, we are a loco noco, as we like to say. Well, I like to say. I don't know if it's a thing, but I'll make it a thing. It's living with low code or no code, using Unity and trying to leverage Unity visual scripting as much as possible, keeping the series accessible and making sure that anyone that is not a developer is still able to create content and generate interactive applications. Talking of content, this is just a little sample of GIFs, which I actually put together for a brilliant event hosted by Drew last week, our first Creator Day. And I wanted to highlight again, the type of content that Ben, myself, and Vanessa have been producing in order to support the episodes. If you guys feel like it, you can try this link. It's bit.ly R2MB04 demo. This is on Furious. It's our episode 4 demo about ingesting real-time data. So both weather data and actually mapping data. This is an experience that we also showcased in the AR episode. I ported this to the HoloLens, again, fully using visual scripting with a little bit of hybrid trickery, because we did need to wrap some of the data processing inside a C# manager. If you're curious about this type of setup, well, everything is actually on GitHub. So we do have a dedicated Road to the Metaverse GitHub organization that I've been updating with some of the content. I can actually switch to it because it has changed since. So this is the GitHub, as you can see. You have a ton of projects. So we have episode 4, episode 8, which is the VR training. We have last month UI building, live learn series. Project that we used to support that learning session, but also the XRI visual scripting extensions that we've been using throughout the series. You can see here there's also a few packages that we have. This one is private. I was planning on doing a custom package for today, but it turned out that I didn't need to, because everything that we produced so far was sufficient to work with the Microsoft Mixed Reality. As Drew mentioned, and I like to put GIFs everywhere, we have the forums. Please join the discussion. Feel free to ask questions or post, the work that you are doing on with the various content or episodes that we've been showcasing. And then today, our session about building a Microsoft HoloLens experience for training in AR. So again, this is an evolution from last month, which was immersive training, so using VR and the XR interaction toolkit. And now I'm going to switch to, we're going to go into demo mode. I'm going to need to quickly put my HoloLens on. There we go. Thank you. There we go. How do I look?
Amazing.
Thank you.
Very futuristic.
Excellent. I should probably turn it on first, which is good. Mm-hmm.
Oh, people are clapping with the emojis, like good and everything.
Excellent. I'm living in the future. The HoloLens is logging me in with my eyes, because yes, iris recognition automatically. I love this. And let's switch to the editor. There we go. So we can look at today's demo. But actually, let me press play. So I'm going to start the holographic remoting. Hey, a bit too close there, the menu. Thank you. There we go. And now, apologies, I need to switch to another window, which is this one, where I have the device portal. And we can switch to the live preview, because that's a bit better than looking at it in the editor. So you should see the wind turbine. Let me see if I can get it to work with the holographic remote, with this, because that's a little bit better. As you can see, we have to use an unsafe. There we go, mixed reality capture, and yes, please live preview. There we go. So it's going to be a little bit delayed compared to what I'm doing, but I'm going to try to go slow. So as you can see, there's a little UI that asks me to start, and it invites me to actually move the wind turbine. I can grab it with long inputs, right? Far inputs, as they call it, and bring it to somewhere maybe a little bit more closer to me. Right now I was at 2 meters away, so I'll put it here for now because that's pretty good. Then I'm going to press start. And the experience starts by asking me to review this solar panel. Right? So this is a wind turbine, a solar wind turbine inspection. So there's two options here. I can either gaze at it. So I'm looking at it right now straight ahead. And I'm going to try to stay fixed for 5 seconds about. And there we go. After 5 seconds, so you can kind of force the user to gaze or to have a closer look at an item. The condition survey comes up. This condition survey is actually anchored to my head. So if I look away from it, it kind of comes back in the view without necessarily centering. There's a way to trigger this to make sure that it's not necessarily straight in your face, which would be annoying for the user. But I can also tap on this, for example, and summon it. So here, everything is okay. There's no visible damage or anything. So I'm going to just say that it's okay and submit. Now, next, it's asking me to look at this other solar panel. Normally, I will move around the actual physical object, but since I'm in my office, this is not going to be the case. I'm using a hologram. And we can see clearly, let me try to stabilize, that this is dirty, there's paint on it. So we do need to summon a cleaning crew. So I'm going to say that this needs cleaning. There we go. And submit my results. Next up, we're going to look at, I can see there's something falling. And yeah, that's no good. There is smoke,
damage.
There are sparks. Yep, that's definitely is going to need some repair. So we are going to either, let's summon some maintenance crew or repairman, or say that I'm going to be repairing this ASAP, and then submit this. And now my training is complete. So one thing that I forgot is we also have this little menu here, which gives us instructions every time I look at my hand. So I don't think you can see this in the feed, but in the video, you can see that when I pop my hand up, instruction menu comes up. So today we're going to show you how you can put all of this together. Not only that, but we're going to show you how you can put all of these together using visual scripting and the Mix Ready Toolkit 3. So let me put this up for now. I'm going to stop the, let me go to the editor. There we go.
I wish you could do that with the Quest, instead of just put it back in your head.
Yeah, it's super convenient. I loved when they released this feature. I was like, this is amazing. And it's very convenient. Although you can still see quite clearly, but right now I have the holographic remoting UI in front of me. So today, everything you've seen is based on the Mix Ready Toolkit version 3. So this is still in beta. For a production application, Microsoft recommends that you use the MRTK, so the Mix Ready Toolkit version 2.8, I think, as of this recording. But we decided to use version 3, and I put a bunch of links here you can see on the slide for you to check out after the session if you want to find out more, especially if you have used MRTK2. There's a nice migration guide on how to switch from one to the other. But the reason we decided to use version 3, it's because it's based on the XR Interaction Toolkit. And if you've been following this series, this is what we've been using pretty much exclusively for all of our VR content, right? So now you don't have to use a new system of inputs or learn a new mechanism to, for example, teleport or grab objects, etc. Everything in the MRTK3 is derived from the XR Interaction Toolkit, right? You have available the same feature, the physics interaction, the native UI interactions, and the locomotion. Although on the HoloLens, you don't necessarily teleport, but you could if you wanted to. Normally, you would move based on the user, right? But it doesn't mean that you cannot, it's fine to teleport on the HoloLens if you are a fully virtual environment, right? On top of that, not only is MRTK3 using the XR Interaction Toolkit, they're also using AR Foundation now. So they used to have their own meshing system, etc., that they had developed for MRTK2, but now they switched, for example, the mesh reconstruction for the SLAM, right? The mesh reconstruction that's that's using derived from the hardware. So whether it's on iOS, Android, etc., they can And now with OpenXR, they are using AR Foundation to pipe that through. So if you have used AR Foundation in the past, you have access to that also. So it's a dependency on MRTK3. You will see if you import the Microsoft packages, they will also pull AR Foundation and XR Interaction Toolkit in the project. So talking of which, we are going to switch to project setup, and I'm going to hand off to Vanessa to take over the demonstration for a second. For a few minutes, I would say. Yeah. You're muted, Vanessa.
There we go. Now we're here. Okay, so yeah, we're going with the project setup for the MRTK3. So I've put two different ways that you guys can do it, and this is the lengthy, difficult, annoying one, and for that we use the mixed reality feature tool. As you can see, I put all the instructions here in case you want to follow it. And although it's very lengthy, I think it's a good exercise to do this, because like this, you can see how many things you need to enable and how many things you need to validate as well. And then we have the amazing, very short, literally 30 seconds one, that what you need to do, I'm going to show you here. Just you need to access this project via GitHub. Just go there, and in the link, you have the MRTK3 branch over there. But if you start in the normal link, let me just show you, you will have the main. So just go into the branch and type MRTK3 and select that. And there we go. And then just download it. Now let me go back to my slides. That I have them over here. I'll just have it on the other.
Yeah, I'm using the feature tool. I have had a few issues when setting up a project.
Yes, same.
Originally I did. There's like some packages funk right now. Again, keep in mind that this is in beta, so it's not necessarily stable in a lot of ways. But I found that the GitHub sample project, I believe, is what they use for QA, so it seems to be working every time I pull it, and it has a lot of baked-in goodness. So
yeah, way easier. So yeah, once we have that, let me open my hub, and what we have to do, just go to the add the project from disk, and in my case, I have it in my downloads over here. So the mixed reality toolkit. You open it, and then you scroll all the way down into the Unity projects. Again, open it and just select the MRTK dev template. Add to project, and as you can see, I have it here. And as well, another thing is, excuse me, the first time that you open this project, the version is probably going to be 2021. So just make sure that you use the 2021 or newer, so it will work properly. I had a few problems with it. And then this is my project here open ready. As you can see in the scenes, it brings a lot of different scenes for you guys. You can try. And then let me just check this is the one, the hand interaction, a template example. Sorry. Let me go back to the slides and I'm going to show you. So yeah, that's the setup and up. So now, once you have the project set up, and in case you don't have a hardware and you want to try it, that's fine, because you can use a simulation. Oh, that's too far. You can use the input simulation. Let me go back and I'll show you over there. Yes. So for that, the only thing that you need to do, just press play and everything is set up for you guys. Now let's wait a few seconds for it to open into play mode. And as you can see, you can use your mouse. You can just turn around and move as well with all the controls. And as well, if you want to make it a bit more immersive, you can just bring the hands. You can change the gesture, bring it up closer, further, and that's just with the controls. Now,
how do you bring the hands?
Oh, yeah, that one. So the right hand is pressing space, and then the left one, you just press shift, and you have both if you want. And you see, you can just try all of these.
And we wanted to make a slide with all the keyboard shortcuts, but there's about 100 of them.
Yeah, so I just put the link here for you guys. Yeah. So I put the link here for you guys if you want to go into depth description of, there is a lot of things that you can do. And as well, let me remind you.
So you don't need a HoloLens to...
Exactly, yeah. Just the simulation no hardware, you can try that. But as well, if you look at this, you have this prefab here, the MRTK input simulator, that I believe it's on all of them. Yeah, so that is what allows you to simulate. And now let me go back to my slides.
So if you start a scene and you don't see, when you press space your hand, that means you probably don't have the simulator prefab.
Exactly.
Just add it to the scene and it should work.
Yes. So that's one way you can do it with the input simulator. And then we can use the Quest 2, and it's so easy. I love this project because it's everything set up for you guys to use. The only the only extra thing that you have to do is just connect your Quest, just enable your Quest.
Fingers crossed, everything
switch
works.
up. Yeah, let's see, because live. Let me see. Let me just connect it. Let me get my controllers.
So I posted the link to the MRTK3 GitHub in the chat for everyone if you're interested. And as we mentioned, not only do you not need a HoloLens, but you can also use a Quest if you want to develop this type of applications.
Okay, let me see. It's very annoying to put this with the headphones. There we go.
Yeah.
So now.
Also, housekeeping, please ask questions in the QA pod, everyone.
Yes.
Not in the chat because they're going to disappear.
And we're in. Oh, this is not the one I wanted to show you guys. I wanted to show you the hand interaction examples. That's the cool one. That's the one I like. And let's go. Let's see that. And we are in. As you can see, I have just my right controller here that you can use. You don't need to change anything. Everything is enabled for you guys. And as well, let me just get the controller away. Maybe let's see if it recognizes my hands. There we go.
Yes.
Whoa, it is.
Woo!
So, okay, I'm a bit too far from it and I'm probably going to go off camera.
You can grab the top panel all the way at the top and pinch that and then grab it and then you should be able to bring it closer.
Oh, I didn't know that. You see?
There we go.
This is so cool. I just love this. It's so funny to see this when you're like not the one doing it, But yeah, you can use your hand to do all of this.
Cool.
And
you can stay in there if you want, Vanessa. Do you want to
tell me?
Can the emulator be used to play these demos? I mean,
say again?
Can the emulator or the simulator be used to play with all this demo content?
Yes, absolutely. Yeah. So
okay, cool.
For that, let me just pause this 1 second. And the good thing with this project is it has the XR enabled already when you start it up. So for that, you go to Edit, Project Settings, and then if you go here and you disable that, and then let's save just in case, Let us save them, sorry.
That's good practice.
And then when you just press play, let me take that off. As you can see, now you use the controls, the keyboard and the mouse to do all of that and just move in and everything. So yeah, so that's for me, guys. Let me just pause these. Let me go back to my slides that I have them here. And yeah, so that is using a Quest 2. So now we did the project setup. We did 2 different ways, and then how to use the input simulation, sorry, and how to use the Quest 2. And now I leave it to Jerome. He's going to show you how to use the fancy HoloLens that I don't have.
One day.
One day, yes.
All right. So let me grab the share quickly. There we go. Yes. And let's go back to screen 1. So for the HoloLens, there is just a couple of extra steps to get it to work. Normally, it's set up by default. But if you can't connect to your HoloLens, if you're new to the device, there is, again, in the project settings. So I have my project here set up, and you can see my project setting, OpenXR. There is this holographic remoting for play mode. There's a holographic remoting for remote app. This is to build an app that's then going to stream to the device at runtime once the app is exported. So that could be like a desktop app that leverages a fancy GPU like the one in my workstation to stream to a less powered HoloLens, so you can get fancy graphics or very large data sets onto the device that wouldn't natively be supported. So that's the holographic remoting. Holographic remoting remote app. That's a lot of remote. But what we're interested in is the holographic remoting for play mode. And this is a checkbox by default. I think it's unticked, so you might need to tick it. And then you have a little settings icon here, which allows you to access the settings. So this is the IP address via USB. So I'm tethered with a cable. I think it's this one. I'm tethered with a cable to my PC using USB-C. And this is the device's address that I'm using to connect to it. The rest are the default settings for remoting. I haven't changed anything. Right? And what happens here, there's an extra step that needs to happen. And for you guys to see it, I need to switch again to my live preview here. So as you can see here, I am looking at the screen, which if I look at my wrists and then tap, I go back to the home screen, you can see it's here. It's the holographic remoting. This is an app that you download from the Microsoft store, and that allows you to connect to Unity. Actually, it allows you to connect to any remoting device as long as you can connect to the IP address of the HoloLens, right? So the HoloLens, the content can be streamed, and you can integrate that into your application so that they find each other with networking and then stream. Basically, it's a video stream, right? So right now I'm looking at the holographic remoting, and then when I enter play mode in Unity, I've set up my remoting. You will see when I go back to the preview. Let me full screen this so you get a better view. I am receiving. Oh, I think it may have paused. Let me go back to live preview. And now basically I am seeing inside holographic remoting the application, right, that is streaming from Unity, right? So it's the same content. So this is really, really useful, the same way that you are, when you press play in the editor with the Quest and you immediately see the application on the device without having to build. This is the same way you would do for HoloLens. So it's a really huge time saver when you're developing, right? So the live preview is stopped, and let me go back to my slides. So that's holographic remoting. Again, I'm using the, you can see that the IP address was a 192 IP address in holographic remoting. So that's basically because the device is connected to Wi-Fi. But it doesn't matter because I have the connection via USB, then I can just use that to connect as long as the IP address is correctly entered in the settings. Traditionally, I would disable Wi-Fi to make sure that it's using the USB connection, but you don't have to. It works most of the time, right? So let's maximize this again. There we go. And next up, well, we're going to stop. I'm going to do about a 10-15 minutes deep dive into MRTK3. There's a lot that has changed and a lot of re-architecture. So even if you use MRTK, I'm going to do a deep dive in MRTK3. If you have used MRTK2, a lot has changed. So let's just have a quick look at what has changed and what remains the same. So this is an architecture of the framework. As you can see, it's based on OpenXR. All of our major vendors are like Oculus and Meta are adopting OpenXR. It's the standard now. It makes things a lot more interchangeable. And obviously, Unity is promoting these heavily also because it's just a great way of working. As you saw, it means that the MRTK3 works flawlessly with the Quest, including hand tracking, and it works also with HoloLens. So it's really brilliant sort of like interchange, a way of interchange work right across devices, and things just work, right? And OpenXR also comes with a lot of really convenient features for developers like project validation, etc. So you can find, conflicting settings or missing settings, so you don't get lost, trying to figure out why something doesn't work. As I mentioned, this is the interesting bit for us, is that it's using the Unity XR interaction toolkit for the interactions. They are their own interactable stack, pretty much similar to the XR interaction toolkit, and they decided to adopt Unities because why not, right? We provide an open source framework for everyone to adopt. You might as well standardize this, let us worry about the nitty-gritty of interactables, etc., and just focus on the higher level components that you need to deliver to users specific to your hardware, right? And also software in this case. So input limiter, as we showed, interaction layers, again, there's quite a few ways of interacting on the HoloLens, which also work for the Quest, but we cover this afterwards. And then they introduced the subsystem mechanism. So this is a new setting in the project setting tab under MRTK3. You will see you have a profile, which is a classic thing that you see in Unity. So you can have multiple profiles depending on the state of your applications or features that you want to enable or disable, maybe based on the platform, right? So you can see here some of the available subsystem with MRTK3, like phrase recognition, for example. You have the performance stats. So this is the little overlay that used to pop up in MRTK2, which you have to spend a half hour to remove because it's like in a whole bunch of settings that you need to clone. For those of you who have developed with HoloLens, you know what I'm talking about. But you can see here, for example, the XR SDK hands API, so you can go back to a different you don't have to use for it the OpenXR one, speech recognition, etc. There's documentation here, but also this is an extensible system, so you can write your own subsystems in order to inject your specific behaviors. If you have developed, APIs for HoloLens, then you can use the subsystem system to enable them or disable them or integrate them into the application. As I mentioned, the interactors and the interactables, which basically an interactor is something that interacts with an interactable. So interactor will be the controller. The interactable will be, for example, the wheel in this case. The interactor could also be the socket where you drop the wheel or snap the wheel to, right? Those are interactors. The others, the things that you grab and carry are interactables. So these are derived from the XR interaction toolkit interactables and interactors. So all those events work out of the box, which meant, as I mentioned earlier, I was planning on having a visual scripting extension for MRTK3, but for the purpose of this demo, the one that I showcased where I was doing a visual inspection, all of the events I was able to use the XR interaction toolkit events, and I didn't need to use the specific MRTK events. I might look into doing an extension afterwards to see if there are specific events that we should tap into, but that probably won't be needed except for specific edge cases that we can discuss afterwards. As Vanessa mentioned, there are a ton of sample scenes. There's also one topic which I forgot to put in the slide, which they have a data binding mechanism that allows you to create scriptable objects in order to sync data sources with data consumers, right? So like, for example, your UI text, rather than update it directly, you can have this data binding mechanism, update the data source, and that will automatically update the UI. Maybe that's something that I might cover next year in a more advanced AR session. We'll see if we have the time. Otherwise, I'll try to post some information in the forum. But this is the sample scenes. Again, the hand interaction example is the everything and the kitchen sink, right? Sample MTM RTK scene is the one you want to use to start from scratch, but it has all of the key components already in it. And then if you want to look at some of the UI and menu examples, the two that I've heavily used for this demo were the Canvas UR tier sheet. So the Canvas, there's two types of Canvas. There's the traditional, two types of UI. There's a traditional UI, which is basically a 3D UI. And then there's a Canvas UI, which is the 2D UI that's in 3D space, right? So you can use both. They have both their advantages and inconvenience, but Microsoft provides both inside the mixed-reality toolkit. And then finally, the hand menu is what I showed. When you look at a flat hand like this, facing the user's face, then it shows up, pops up a menu, and we're going to cover this after. I'm going to deep dive on this in the second half of this session. So UI system, as I mentioned, there's a lot of pre-built components that you can tap into. Buttons groups. As you can see here, this is a button group, for example. Sliders, dialog box, toggle collections. If you remember the little menu that I showcased with the report, right? Whether something was clean, was okay, needed cleaning, needed repair, needed replacing. This is a toggle collection, and basically the toggle collection keeps track of who's selected and deselects everyone else. You don't have to do anything. You just have to tell it, hey, select, the toggle index 3, and it does it automatically. So it's a really convenient system. As you can see, everything is resizable, customizable. It's really easy to update the UI, the standard UI, to your needs. And I've included here some information, and we'll have a link to the design for mixed reality. It's part of the documentation, and you can see that again they have the canvas-based UI, canvas example, and then the traditional UI. So this is the 3D space UI using mesh, etc. Super customizable. They have an icon font, which is really good. They include, they use obviously the TextMesh Pro, either 3D or UI, and also this new bounding box, which is really cool. I love the new occluded and rounded corners. It's a really nice way of designing. So even if you're designing for Quest, there's a lot of really good UI elements here that you can recycle for your Quest-based applications. Again, MRTK is fully free and open source, so you can customize and use it to your heart's content. Some more specific things to HoloLens. I was joking with one of my friends who works at Microsoft that the first thing that when we got the HoloLens 1, we were one of the first few in the UK, the agency that I worked at, to get a device actually that was flown to us from the US because they weren't on sale at the time here. And we did a demo for a customer. And the first thing that I wrote was a little script that would anchor the content close to the user, right, as you move about, so the content will stay there. And now it's included in the framework. So back then there was no MRTK, there was not even a Holo toolkit, which was the ancestor to MRTK. You had to do everything manually. But this is now included out of the box. So I showed you the hand menu. So when you look at your hand, basically you can pop up a menu. This is part of the solvers, they call them, and we're going to look into that afterwards. But the hand menu allows you to anchor content to the user's hand, and then they can make selection near, right? So this could be something like reviewing instructions or going to the next step, or summoning a specific menu or something like this. And then you have the near menus. So they don't have to be menus. Any content can have the solver, which basically is a radial view, and it anchors the content to the users regardless of where they are in 3D space, right? So this is really convenient, for example, for the dialog boxes, etc. So they always pop up in front of the user regardless of where they're looking or where they are in 3D space. You don't have to worry about it. You don't have to parent everything to your user's head. You just put that solver and it would find itself, it would position itself to the user. And then there's some really nice variables you can tweak to make it more convenient to work with this. Obviously, there's also the capacity to interact with the real world. So using the real world mesh in MRTK3, this is not as mature and as in MRTK2. Again, as you can see in the documentation, that say that there's no feature parity yet between the two. So again, if you're doing a production application today, I highly recommend you look at MRTK2. If you're just tinkering about or looking for something a little bit further in the future, MRTK3 hopefully should come out of beta soon. I don't know when, but you can ping the dev team to see what's their roadmap for release. But again, this is also leveraging the AR Foundation API. So the mesh data is piped through AR Foundation and using standard Unity way of handling the mesh, but you can, get at least the room mesh in your application and then interact with this. If you want to drop an object, for example, throw a ball and have it bounce in the room, then that's possible today with MRTK3. But some of the more advanced spatial awareness, I haven't found yet parity with this. So for example, give me, a 2x2 meter space on the wall, right? This type of queries, although that might be actually included in AR Foundation. So something to check for later. And then another key aspect of the HoloLens is object manipulation. So there's a bit of a new concept for people that come solely from VR is that the HoloLens is transparent, right? So I can see everything that's behind, which means that most people that have a HoloLens will actually interact with physical objects. So hand manipulation or hand interactions might not be possible. And for this, the MRTK provides a multitude of ways of interacting with content. So the first is if your users are going to be busy with their hands working on physical objects, like tools and etc., then using gaze, so just looking at, for example, the interface and then dwelling, like I showed with the first solar panel, where I can just look at it for a little while and then it would pop up a menu. This is a good way of interacting, so I don't have to let go of anything in my hands, or I don't have to necessarily poke or select a button, right? So you can actually combine the gaze, so HoloLens has eye tracking, so it's pretty precise. So I can look at a button and just say select, for example, and the API is smart enough to carry that selection and then action without having to touch or do anything with your hands. If the users, like in my demo, are going to be using mostly holograms, for example, then hand manipulation is always more precise. Controller also manipulation, for more precise, granular interaction is really good. I've included some resources here which are really useful. The first one is actually a QA on the documentation, which is brilliant. That's basically helps you to select which type of interactions you should be using based on the use case for your application. Then there's direct hand manipulation, which is a new concept on the HoloLens 2. So if for those of you who've seen the HoloLens 1 or have used the HoloLens 1, they had a concept of proxy gestures. So you couldn't grab directly an object, you had to point at it and then pinch like this in order to select it. Now with HoloLens 2, you can just grab it with your hands or grab it like this, and then you can interact with the object directly because the hand tracking is just better now. And then finally, there's resources on hands-free. So there's hands-free is basically gaze and dwell. So you gaze and wait for a few seconds. If you remember the three DOF kind of like cardboard experiences, you would always have to stare at a button for a little while, then get a countdown and select. This is pretty much the same thing. The only difference with the HoloLens is you also have a phrase recognition API. So this is different than, phrase recognition is you preset a sample instructions, right? Like select or, open, and bake them into your application. There's a setting where you can instruct the API to recognize those phrases. I think it's mostly English, but there might be localized versions. And this will do simple commands like this. Then you can use natural language processing, which is what we used in the demo for episode 4. Maybe I can show that in overtime, or if we have a little bit of time at the end of the session. That uses the Azure speech recognition API, so you can send a command and Azure will validate what you said. So like, for example, a CT or something like this, or something that you don't want to pre-program. So these are the two ways you can do hand-free. You can use the command, or you can use natural language processing, whether it's Azure or something else, to do so. And now I'm going to switch to Unity, and we're going to look at how we built that demo. Hopefully everyone is still with us. I know it was a long exposition today, but there's a lot to cover on that platform. It's a pretty mature platform, but let's dive in, unless we have some questions.
Yeah, we got a number of questions in here right now. Let me just grab one off the top from earlier today. MRTK3, is it basically supported on any VR set, right? Does that include every set, OEM, or any flagship brand, or just a specific brand?
So for now, it's supported on anything that supports OpenXR, right? So that's the HoloLens, the Quest, and hopefully the Magic Leap, I think. I'm not sure if Magic Leap 2 is using OpenXR, so I'll have to get back to you on this. But officially, that's what they support. But with OpenXR, most other headsets should be able to work as long as they support OpenXR. I think Steam VR is an OpenXR implementation. Don't quote me on this. I haven't used a Steam headset in a while. But yeah, that's the idea, right? So as long as the headset supports OpenXR, or the vendor has an OpenXR compatibility layer, then it should just work. Famous words, but that's the idea.
Cool. And Samson in the chat called out the HP Reverb G2 as well. Just
I haven't,
Test that one.
yeah, I haven't tested. Those are Windows mixed reality devices, so they should work because this is, again, if you look at the subset, it doesn't say HoloLens, it's mixed reality, right? So any mixed reality device should work using this setup. Good.
All right, awesome. We've
Awesome.
got plenty more questions to go, but we'll be able to get back to those at Q&A.
All right, cool. So let's go back into the project. Let me pop in my notes so I don't miss a step. And yeah, first of all, in this walkthrough, I want to go through again the scene structure, right? So this is my hierarchy here. You can see it. Hopefully it's big enough. Oh, shout out to my colleague, Brian, who said like sometimes it's hard to see what's on the screen. And I found this brilliant little thing, which is the magnifier. Check this out. Ooh, fancy. So, isn't that amazing? I love it. So you can see here we have the MRTK XR rig. That's basically the root of everything. It's very similar to the XR interaction toolkit rig. You have a whole bunch of things under it, right? Like the camera offset, etc. It's very similar. You can see they have their interaction manager and the canvas proxy interactor, which basically is what allows you to interact with canvas-based elements. We have the input simulator that we showed before. That's available in case you don't have a device. And then we have our event system, pretty classic. Then in that scene, I have what I would describe as anchored content. So we have the condition survey. So that's the little survey that pops up. I can select it and then we can focus on it. You can see it here. Here, I'm going to stop this zoom for a second. So you can see the, let's switch like this. So we have a bit more space. There we go. So that's the condition survey and the hand interaction, the hand info panel. Again, this is, these are anchored objects, and then inside also the step 0, which is the start panel, right? That's the panel that tells you, hey, welcome to this, and press start to begin. And then we have the movable scene content, which is all anchored in here. And you can see that in here we have our wind turbine and we have each of the steps, right? If I select the steps, you can see that step 1 here is just looks like a bounding box, but there's actually a box in there. It shows that I'm not rendering it by default. And these are anchored to this because when I select the base here, I can actually move that whole structure to wherever I need in the room. So all the content that's anchored to this wind turbine, I parent it to this movable object, right, to keep it simple. And then this gets moved when you grab the base and move it around. So that's the idea. Then, as I mentioned, there's the steps, which are also anchored in that scene. And then finally, there's a visual scripting component, which are up here. You have your classic scene variables. There's only one here, which I use, which was the default hover enter color, which I ended up not using actually because the object is hidden. And then we have our state machine, right? For those of you who are have seen the previous couple episodes, you know that we've been using state machines to track the current state of the application, right? And I'll cover this in a second when we go into visual scripting, or actually if we don't have time because we're already quite late in the session, I might do that in overtime. So the first component of the MRTK setup is the stateful interactables. Stateful interactables, that sounds super fancy, but basically it's this thing here. This is a component that's attached to each of the solar panel, but also the blades when we inspect them. And this is what allows us to interact with them. So if you remember the XR interaction toolkit, it was like a grab interactable or some sort of base interactable thing, or simple interactable, I think is the simplest one you have in XRI. That allow you to basically interact with something, grab it, click on it, do something with it. This is exactly the same. You can see here, there's even our classic XRI events, which are inherited by this object. It's a descendant of the XRI, it's a child, sorry, or generates from the XR interactable events. You also have some custom MRTK events, a whole bunch of them, because it's, again, there's many ways of interacting with this object. But here, what I want to focus on first is the fact that this, if we go into the advanced stateful settings, we can see that this has been enabled to use dwell. So dwell is basically gazing, looking at an object, and there's a dwell time of 5 seconds, right? Use far dwell is to look from a distance, so there's a minimum distance here, which differentiates between near interactions and far interactions. I believe that's set in the global settings. And you can see what I was saying before, there's also allowed select by voice. So if I say select when I look at this object, it's gonna basically do the same thing as a click or as the dwell and hold, right? So very useful. And then another setting which I have open but might not be open by default, which is really useful, is the disable interactor type. So if you want, for example, this to be a gaze only interactor, and you want to disable like the pinch or the poke, I mean the select or the poke, for example, directly, then you can add a element to this and say, hey, I don't want the speech, for example, to work, or even if I don't want the grab to work, and that will disable those interactions with this object, right? So really useful way of filtering. And then on this object, you can obviously use the XR interactable events, as I mentioned. And if I select this, and we're gonna full screen the visual scripting, and I'm gonna zoom in here, you can see this is, I should have probably put a comment here so we can see it better. In case you didn't know, you can put comments in visual scripting like this, right? So this is the select event, right? And on select entered, so when I gaze for 5 seconds or when I click or poke it, then this is going to send a notification to the application, which is, the notification name is here. It's an object variable that says condition survey show. So that's going to show a little survey to the user so they can report on the state of this. That's it. That's all that's here. And again, this is an XR I event. If you're wondering where they are, if you have added the package to your project, they're under events, XRIT, and then you can see all the events here that are coming from the XR interaction toolkit. And this is on select entered, but I believe it's, you can use on select entered, and on select, exited is when you release, right? So entered is the basically like the mouse down, exited is the release. So that's the this section. Then let's look at quickly the anchored content. So this, I was telling Vanessa when we were working on this project that I can never remember the name of this component because it's not called like near menu or anything. It's called a radial view. And what the radial view does, so if we go back to the survey UI, you can see it here, and it aims to anchor content to, in this case, the user's head. So this is a solver. That's why it's called in MRTK land. And this is the solver handler. The solver handler is there to basically refresh the information, and it's gonna execute all the solvers on that object. You can have multiple ones. You can create your own, for example. This is an extensible API. But in this case, what we do is we have a animated menu that is going to aim to stay in front of the user. We can see that it's going to try to stay within 10 degrees of the user's gaze, right? So it's going to reposition itself kind of like at the edge of your of the user's view. If you put that to 0, it's going to reposition to the center. If you put that to 30, it's going to be, or minus 30, it's going to be on either side of the user's head. Well, actually, it's usually 30 because it takes care automatically of adjusting itself. But in this case, we have 10. And then here, I have a little bit of vertical offset. So it's going to be a little bit lower than the user's gaze because the menu is quite long, but you can also put it higher, etc. So here you have options. And then what the solver says is, anchor it to the head, anchor it, for example, to the hand joint. So that's when we look at things, but not necessarily, right? So the menu can stay all the time at the hand joint here, right? On my wrist. To the controller, if I'm using a controller, or if I'm using my my pinch or point gesture, or an interactor, which is another object, right? So you have options, or you can do a custom override. You can have your own object that you can anchor to. And again, these little settings here is to automatically update all the solvers. If you want to handle that manually, you can untick this and update the solver whenever you feel like it or what makes sense in your application. So that's the way you anchor content to the user. And in our case, it's anchored to the head of the user, which is where the HoloLens is. The other option is the hand info panel, right, which was showing up when I was looking at my hand. And that's, again, the hand constrained palm up, which is basically this, right? When I look, palm up is when it faces me, when my hand faces my face, and extends the hand constraint, which is itself a solver again, right? So that's why we have the on that somewhere we have a solver handler again, and you can see here that it's anchored to the hand joint. The track joint is the thumb metacarpal, so I'm assuming it's this side, right? And then there's also, you can see here, there's a whole bunch of I think there's 21 joints that are being tracked by the HoloLens for the hand, and you can decide where you could put it. So if it's a proposal, you can put it to the ring finger, to the index finger. You can do whatever you want. So these are all the options.
That's very specific.
Yeah, these are all the
you
options.
really need to know that.
Exactly. It's all in the docs, really well explained. But yeah, so you can anchor the content wherever it makes sense. Again, you can offset it. This is a very similar settings than the other constraints. So you can see here that we're using the thumb metacarpal. So I'm assuming it's around here, but we are on the ulnar side versus the radial side, above the fingertip, below the wrist, atop palm. So there's a lot of really precise settings in order for you to anchor that content to the user's hand. And again, this works, the hand menu also works in Quest, right? So if you're using a Quest and not a HoloLens, because the hand tracking is similar, it's all using OpenXR, then you get access to that data also. I don't know if they track as many points, but something to be tested. So that's the hand constraint. And then finally, we have a couple of more components which I wanted to cover. One more thing, you can see here that we have custom events. So this hand constraint is extending and is providing its own events. So on first hand detected, on last hand lost, right? And you can see that these basically either show or hide this container. And this is the container that has, oh, I'm on the wrong menu. So let me go focus on that, right? This basically show or hides this game object, right? That's what the container does. This was set up already. This is a prefab or a component that I extracted from one of the examples, right? So it's super easy. And I actually reuse that same setup, so you can see each step here has a child, right? That says content. And actually, that's one of the next things I want to focus on. So this go around, I have set up a prefab, which is called a step. Last time they were not prefabs or standardized, but they all share the same script, which is step. So that's the visual script. It's super simple, this one. Actually, because all it does is show itself if the current training index, so if I'm step 0, 0 is going to show. If it's step 1, 1 is going to show. And this is using the notification system that I wrote, which is, if when a step starts or, on step started, check the index that's being sent with the event. If it's the same as mine, then activate. If it's not, deactivate, right? And all it does is activating and deactivating this content based on this value here. So these are variable on my game object. Super simple. The main difference, if we look at the state machine compared to last time here in the object variable, I had a list of steps, right? I had like 5 steps that we were going through. So the state machine had to be aware of the steps, and the steps had to be aware of the state machine. They had to communicate with each other. And again, that's not scalable, prone to errors. It's not very clean. So in this case, I did everything with the notifications. So if we go into, so I should probably cover these for, if in case you're not familiar with state machines are very much like graphs, so like script machine, except they manage states. So they don't they have a different purpose than a script. They're not going to rotate an object that's just going to manage the state of the application. That's the idea. So here, when we enter the state, so when we start the application, we set the current step to 0, right? Because we're starting, and then we send a notification, hey, step 0 has started, update yourself. And then we send a notification with the instructions for the end instructions to tell the users, in case they forgot what they're supposed to be doing, they can look at their hand and see the instructions. In this case, it's, place the wind turbine wherever it's convenient and clicks or tap start. So if we go back to the state machine, we can see that this is the start. And then to go to the first step, we are waiting for this notification that said, hey, the current training step is complete, proceed. And this being sent by the start button when I push it. And then the subsequent steps, this complete event is being sent by the menu, the review menu, where you pick the state of the item and then press submit. That submit says, hey, the step is completed. In actuality, it should send the data to an API, wait for a response, and then go to the next step, right? That would be the idea here. But that's the way the state machine is set up. And then basically, it receives events like, step completed, and it sends, instructions to someone in the scene to do something when we send step. It doesn't know about the steps, doesn't care. All it knows is that, whenever a step is complete, it just increments or, go to another index and then sends that to the rest of the application. So it's a cleaner, more modular way of structuring applications. So that was the long-winded deep dive. Obviously, we'll share the slides with you as usual right after the session. I'll put them on the forums under today's session. The brilliant wind turbine from Rifki. I had to send him an email because that's the third time we use it. This is from GrabCAD. It's a cat bottle. I data prepped it really simply today. I can tell you quickly the steps, maybe in overtime if people are interested. I'm using my visual scripting extension for XR Interaction Toolkit, which is available on GitHub, and I'm using the notification, visual scripting notifications, again, that are available on the Road to the Metaverse GitHub. So again, custom events are messy. They're very tightly coupled. It's basically, picking up the phone and calling someone. You got to know who you're going to call, and you have to have the number. Whereas notification, you just send an instruction into the wild, and whomever is interested picks it up. It's kind of like Twitter or Mastodon, right, where you notify your followers of something, without having to necessarily, tell each and individual one what's happening. So it's more easier to scale and reduces a lot of the errors. Go back to the last episode. I did dive into how to set up notifications. Here are some of the three components, are a notification asset, which you create inside the project menu, and then 2 visual scripting nodes, one for sending a notification and the other one for handling notification. Both of them can send or receive also variables, just like the custom event inside visual scripting. And again, recap, these are some of the examples of what we've done so far in those 9 episodes. I put some content from the live learn sessions too, because those are really fun. Tons of stuff that's available. Some of it is on GitHub. All of it is available on demand. So if you haven't watched them, it's the holidays, just go back to the site and watch them on demand. They're fun. Usually to rewatch or follow along some of the instructions, because we have to go pretty fast. Next live workshop, our friend John from my team, John Fusher, is going to join, and we're going to do some Arduino actually connecting to Unity. So that should be fun. I'm going to run through some of the IoT APIs available for Unity and the SDKs, etc. So that should be a really nice one in January when we come back. Next week, Vanessa and I are doing Intro to VR. That should be fun. Again, we're going to recap some of the stuff we covered in previous episode on this series, and we're going to do like a stepped getting started with VR. So that's next week. If you're still around, if you're not on vacation, feel free to join. The link is there, and obviously you'll have it in the slides. GitHub, check out the project, start them, use them, integrate them into your projects, poke them, break them, contribute. You're welcome to. This is a living project. There's a lot of good stuff there that you can learn from. Forums again, please join the conversation. Socials, ping us on social media. Tell Ben how much you miss him, so he can
Do so, yes.
so he knows that he's still loved and comes back next year rested to the series. And now we have maybe a little bit of time for Q&A. Sorry, Drew, I was really long.
No, that's fine. Absolutely fine. We do have a lot of questions though, so let's see.
Right.
Let's jump right into them. We'll just keep your screen share up as well.
Cool.
Okay, first question. Both MRTK3 and XRT have multiple similar events. Which one's recommended to use, or does it matter?
It doesn't really matter. If you want to use the visual scripting extension, then use the XR interaction ones as much as possible. They map out pretty easily. If you're not using the visual scripting extension, you're okay with C#, etc., then use the XR, the MRTK1 if you need specific events. But theoretically, you should be able to just use XRI for most of them. I don't know if the, other than registering for a very on gaze enter, for example, event, which is very specific to the mixed reality toolkit, you can on hover enter is the event that you would get in XRI, right? But it's not going to differentiate between whether it's a finger or it's a gaze event unless you filter them on the component itself. So, same difference. I've used for this demo only XR interaction toolkit events because I was using the framework for visual scripting.
All right, awesome. Sorry, just bouncing around the chat a little here. Okay, next question. I downloaded a neat tactical glove off Sketchfab that I'd like to drop in and make the phantom hand for my AR experience. And that's pretty easy, right? To drop in any 3D object and make it your point of reference for a virtual hand?
Yes and no, because there's the animation part. So that I don't know how to create custom hands. I've seen them on the asset store, so I'm assuming it's probably like blending, kind of like what they do for facial deformation. So yeah, I'm sure there's a tutorial out there. I haven't done it, but as long as you can create the blend shapes or rig, right, for the hands, then it should be okay. But that might need a step that you need to do manually. As far as Sketchfab is concerned, there is a plugin to import and export to Sketchfab from Unity. So that should be pretty straightforward. Love Sketchfab.
All right, awesome. Next question up here. Have you used the Pico 4 at all? HoloLens is a bit out of reach money-wise.
Yep. Pico, if you're listening, I'm happy to try it. No, I haven't. I'm on the industrial side, so I speak mostly to non-game industrial customers. It is quite popular. A lot of enterprise are reluctant to adopt Oculus, or especially they were reluctant to adopt Meta headsets because of the requirements for Facebook accounts, etc. So they went with Pico for industrial use cases, and apparently it's an excellent device. So everyone I talk to is really happy with it, but I haven't tried it. So if you don't have enough for HoloLens, which is understandable, it's a very expensive device, then use the Quest. A Quest is enough to get started. Use the simulator, although it's kind of cumbersome a little bit to really create a full experience just with the simulator. But a Quest or a mixed reality headset like the Reverb, for example, will do for development, and you can score those for pretty inexpensive. They're pretty expensive these days, right? Or get a Rift or a Rift S. Ben always uses his Rift S because it's easier than the Quest to set up, and it's doesn't go to sleep like the Quest does.
For sure. All right. Next question up here. Will hand interactions work with the Quest Pro with no controllers?
Yeah, it works with the Quest 2, so it will work with the Quest Pro. They Meta switched to OpenXR, so everything that uses OpenXR should work out of the box. All
right, awesome. Okay, next one here. I'm a university professor, and I'm looking for a course that has a specific focus of creating interactions in the air. I follow specific tutorials from Unity, but I'd like to know if there's any resources, recordings, webinars, that kind of thing, or professionals you can put into touch with who offer mentoring just in creating specific, interactions with kind of air-based UI.
Air-based UI. I'm not sure what that means. Like if it's but yeah, ping me. You have my details, or post in the forum, and I'll point you in the right direction. Yeah, on today's session in our forums, feel free to post. There's people that we can put you in touch with for EDU, either on social media, right, Twitter or LinkedIn, or in the forums. This is the link, right? And today's session is there in one of the official threads, so you can post in there if you want.
Awesome. And yeah, in addition, I'd like to follow that up as well, because we have a question, someone looking to host like a large app on PC, want people to remote in. They're looking to have like a digital twin of an airport with repositories of knowledge, different hangars, and a flight sim, 3D renderings of optical top bench equipment. I feel like that discussion may be a little better suited to the forums. I'm not sure if we'll be able to really dig into that remote launch airport app that you're building there, but that'd be a great conversation to bring into the forums as well.
Exactly. And also to get started, this is what I mentioned earlier. This is the holographic remote app setting, which allows you to basically stream to devices that supports holographic remoting. In this case, it's mostly the HoloLens 1 and 2. So that's what people have been doing it. There's documentation on the Microsoft website on how to get that started. Obviously, the device has to find the PC hosting the data. If you're not using a HoloLens, if you want to go into other devices, then the NVIDIA Cloud XR API is probably what you want to do. So that's for specifically non-HoloLens devices, and it's remote rendering streamed to the device. That's compatible with Steam VR. So, most VR headsets should be suitable for Cloud XR.
All right, perfect. Okay, I know we've kind of answered this one in other questions already, but will most of the HoloLens 2 AI interactions in MRTK3 work with the Quest Pro?
Yes, most of them. There's only some hardware-specific things, and obviously platform-specific things like Azure, etc. That needs the Azure SDK to be implemented, but it should work. Some of this also works on mobile, right? It's going to work on mobile. It's going to work with the AR Foundation. It should work with iOS and Android. Mobile-based AR. So the original MRTK, when the MRTK2 was compatible with these. I haven't tested with MRTK3, but I think it should work. It's mentioned in documentations anyway. They mentioned mobile. So,
all right, awesome. Okay, next question up here. Besides the existing demo, what else can we do, such as importing 3D objects or make some interactive?
Yeah, just go back to episode 2. We spend an hour showing you how to import pretty much everything under the sun in Unity, from photogrammetry to LiDAR. Get those objects inside Unity and start creating experiences, right? That's the idea. You can use visual scripting. We showed you the state machines in order to create more complex applications. You have a notification system to decouple actors and really have complex systems interacting with each other in a scalable way. So, I invite you to go back to the beginning of the series from episode 2, where we deep dive into each of those topics and see what you can come up with, right? The idea is to create the experiences of the future. And if you want to prototype, if you want to explore, there's also some really brilliant tool like OpenBrush, which is the new version of, or Multibrush, which are new versions of TealBrush from Google that was deprecated but released open source. You also have things like ShapeXR or Gravity Sketch, which allow you to sketch and design experiences in VR, or for AR, for immersive AR. So there's a lot of tools out there to tinker with, to play with, and get the creative juices flowing, and then take those ideas inside Unity and start creating.
Right, sure. Okay, got a number more questions to go through here. Next one, I have an access to a HoloLens 1. Can I try what you presented in this session?
Good question. I think so. The only thing that will not work is direct hand manipulation that was not supported on HoloLens 1. So it's going to be proxy gesture, like pinch, like it's basically there's the near gesture, which is when you grab stuff, and then there is the far gesture, right, which are the original kind of like proxy gestures. So those should work with the HoloLens. I haven't tested with the latest version of Unity. Worst case, you may need to go through holographic remoting if things don't work. That's still supported on the HoloLens 1.
Yeah, for sure.
1 second, I'm going to take off my HoloLens.
No worries.
I think I have a big red mark now.
That'll happen after a while. For the World Anchor, Fuse in the project, does Microsoft Azure service have to be used?
Well, out of the box, they would love for you to use it, I'm sure. But no, you can use other solutions as long as they have. I mean, if you go to HoloLens, stuff has to work on universal Windows platform, right? So that's a big requirement. Not every API may have an implementation. So check if they supports universal Windows platform, then you're good to go, right? Otherwise, yeah, it's going to be difficult. Again, like when you build for HoloLens, it has to work on that platform, right? Which is restrictive because it's not like traditional Windows. There's a lot of restrictions when it comes to security and performance.
Yeah, definitely. Okay, next question up here. I'm wondering if the XR interactions are compatible across the board. Sorry, that what you create in HoloLens can work in pass-through for Quest 2 and Quest Pro.
Yes, definitely. Yes, that's the idea, right? Because everything, what I love about this ecosystem is because everything is based on either standard Unity things, so it's standard for Unity, not standard for everyone, and OpenXR, which is standard for everyone, then that should just work, right? As long as the headset support OpenXR. Obviously, OpenXR is a set of implementations that you need to support. You don't have to support everything, but whatever, is supported by the device for OpenXR. Some devices may not have hand recognition, for example, but they provide controller support, so you can use controllers to interact versus your hands, right? So theoretically, every device that has this support works. I believe Quest gives you access to the mesh also, so you can interact with it. And again, that should be bubbled up to the applications via AR Foundation or some other mechanism.
Okay, excellent. All right, next questions. Can this system work for phones? For example, the interactable stuff like and speech recognition.
So the speech recognition should work for phone as long as I don't know if out of the box the action work with speech. So that might either need to be implemented through a cloud service like Azure. Yeah. So that's the main thing. The interactions, like tapping on the screen to select an object in AR, interact with an object in AR on the device. Yes, that works.
Okay, awesome. Okay, next up, are there any resources on best practices to display AR and VR experiences, to display menus like in HoloLens or other HMDs?
Yes, there is in the episode about the R's. We introduction to AR VR, and there's a slide in there where we painstakingly went through the device documentation and extracted their best practices and recommendations. So it's in there. It's on the forums. If you can find it, post on the forums, and we'll point you to it. But yes. There's again, it's it's for information. It's really dependent on what you do. I have a slide also that I think it's in the session on getting your assets inside Unity. I have a slide on data preparation, data optimization, or a few slides actually. So that's episode 2. You can go to that. The slides again on the header in the forum, you'll have the link to the watch on demand and the slides. And if there is a project, I also list to the GitHub repository for this. But in the slides, you'll find a few, in the slide presentation, you'll find a few slides on how to optimize data. So we use, in this series, I've been using Pixie Studio and Pixie's plugin, which is our own tool to do data preparation. So, simplify the hierarchy, optimize the mesh if possible. If you work with CAD data, obviously you can really optimize the mesh nicely. If you work with tessellated data, like the wind turbine is actually a mesh when I download it from GrabCAD. So that too, you have to retopologize this in order to recreate a new mesh. So it's a bit more complex, but if you work with CAD data or BIM data, then you can with Pixies, you can do some really nice optimization and really crunch that asset. That wind turbine is 500,000 triangles, so it's not too bad. It's in line with what you should use on the HoloLens. But it could use some optimization. I'm sure if I spent a bit of time, I can probably get it down to 100,000 triangles, and it would look the same.
Right, awesome. Okay, next up, is there any documentation on real object recognition with the HoloLens?
Yes, again, in the introduction to AR, VR, and XR, and all the Rs, I mentioned the name VisionLib. Vision and LIB, VisionLib. It's a API for HoloLens and AR Foundation and ARKit, which does really good object recognition. And you can even use like the CAD data in order to create the object marker, quote unquote. So it's very precise. And they have a pretty good licensing model because obviously it's a paid for API. I mean, paid for plugin, but I believe you pay per object that you need to recognize. So normally you're not going to recognize the whole world, but if you have your own data, like a shoe or something very specific to your company, then you can create a marker for this, and then the content will be precisely anchored to it. So it's really good API, VisionLib. They have an excellent implementation inside Unity, and I know industrial customers that use it to do like training, for example, to recognize the parts that need to be assembled really precisely, and create some really good training modules with that. Vuforia and I think ARKit also now have simple object recognition, but these are pretty rough. If you need precision, VisionLib is the best one that I've seen. And if people have a recommendation, post them in the forums for everyone to know, right? Because these are the ones I know, but there might be others out there.
Definitely. Oh, pardon me, catch my breath here. Do you know of any way using MRTK3 to launch Edge, the Edge browser, an app? They did this in the MRTK2 examples hub app in the hand interaction scene.
I haven't tried it. I would assume it's possible. I mean, that would be a shame if it's not. But yeah, it should be possible.
Okay, cool. Any word on HoloLens 3? Or does Microsoft plan to defer future hardware development to other companies?
Like they would tell us. I don't know. What I do know is a lot of devices are coming online which are similar, to HoloLens, and maybe lower specs, right? So less expensive. But Qualcomm just released what do they call it? Not a sample device, but a reference device, right? Specs for a head-mounted glasses, nice and light with SLAM, so fully immersive, using the latest, I think it's the XR2 Plus chipset. So it's coming. Like a lot of vendors are developing similar devices. So I'm pretty confident that this space is going to evolve. Whether it's HoloLens or not, I don't know. But again, HoloLens is a very expensive device, so not everyone can use it or afford it. If you don't have a HoloLens, use Quest Pro with pass-through is probably the next best thing. And then after that, just use a Quest to do a development in VR, or a Pico if it's supported. I think Pico supports OpenXR anyway. So these type of devices, in order to do your prototyping, and then eventually test on the actual HoloLens hardware.
For sure. Actually, speaking of Quest, how does the AR experience on Quest using cameras compare to the HoloLens 2?
It's vastly different. So Quest 1 and Quest 2 are very rudimentary. You have black and white, very grainy video. I haven't tried the Quest Pro. Meta, if you're listening,
Wink.
we'll take a device just to try it. We'll send it back. And actually, one of my friends from Microsoft tried it, and he said he was really impressed with the progress of the camera feed. But it's still, a video feed. It's not the real world. It's a bit distorted, obviously, because it's reconstituted, but the latency is much better from what he's seen. So it's really good step in the right direction when it comes to pass through. If you really want, the best in pass-through and VR technology, then there's Vario, right, which is really the high end, but nothing gets better than that. They have, high resolution, stereo cameras, pass-through, along with, best in class VR rendering. So, that's the spectrum right now when it comes to hardware. Hopefully more stuff comes online that really speeds things up, or, builds momentum for this technology.
Yeah, definitely. And I guess make that 4 Quest Pros. Give one for each of us. One for Ben too once he gets back.
Yeah, we'll see.
If anybody's listening.
Yeah, that could be a good carrot to dangle for him to get back faster.
All right. Okay. A few more questions here. Have you done any demos on surface magnetism where you can drop a hologram onto a real world object and have it stick to that object?
So there's 2 steps there. Is first of all, you need to recognize the object. So that would be something like Vision Leap, or maybe with a QR code or a marker or some sort of feature, just to know what to magnet to. But then once you have that object, you can use a solver, as it works for the hand or the head, to just anchor content to it, right? It's as simple as that. And remember that MRTK is an extensible API, and they have documentation on writing your own solver for specific use cases. And that sounds like a good use case for this, right? Once you know where that object is in the real world, you can use a solver to anchor your content to it.
Okay, awesome. All right, next question here. How do you find working with rendering tools like Blender in conjunction with developing an application like what you've been showing off today in your demo? This is kind of just open-ended, if you just wouldn't mind sharing your expertise and experience.
Yeah, sadly, I don't spend a lot of time in 3D land. Most of what I do is I ingest 3D assets. I mean, not me, but software-wise, I don't eat them for breakfast. But I would take them into something like Pixie Studio in order to data prep them, right? And usually the workflow is, if you look at episode 2, the data preparation slides, is simplification, right? Simplify the project tree, so the hierarchy, simplify to the maximum, reparent things, maybe leverage the metadata. Some format comes with metadata, which is more than just the position, scale, rotation of an object along with the mesh. There's also, there could be the model number, the price of that item, a reference to its material, for example, what it's made out of, like wood or metal. So, you can leverage that in the data preparation step to create smarter model and then take that into Unity. So that's my workflow. I know Ben, for example, uses extensively Maya for 3D modeling. You can also use, you can do some pretty good 3D modeling directly inside Unity. Actually, Antonia reminded me of my colleague Antonia, who's an advocate on the game side during Creator Day Friday, reminded me that we haven't mentioned a lot Pro Builder. Pro Builder is a package that's free and available inside the package manager. It was an acquisition and integrated inside Unity. And you can do 3D modeling inside the editor. So for your VR application, if you want to do, for example, a set of stairs, Pro Builders has a stair generation tool. You can even do curb stairs, etc. So it's really good for creating prototypes directly inside the editor that can just send to Blender or send to Maya and Max. You can also use them to do simplified colliders, for example, for complex objects, and nav meshes. It's really good for that too. So you can, kind of draw the nav mesh directly inside Unity if you have, agents that are going to be walking about your application, right? So a really good Pro Builder, highly recommended. I'll have to put a link in the forum so people can find it. Yeah, and sadly, there's no there's no easy round tripping between Blender and Unity the same way we have with Maya and Max. There is Mesh Sync, which is a package, a open source project from our Japan colleagues. Mesh Sync is a mesh synchronization, so that synchronizes the items inside Blender to the item in the scene inside Unity. So check that out. It's called Mesh Sync, like syncing. And if you Google it, the repo should show up. And it's a good way to synchronize your work between Blender and Unity. It supports other packages, but specifically for Blender, that's probably the one that I would go to.
Okay, awesome. Okay, our last question up here for now. Is there a way to launch Teams in-app on HoloLens 2 using MRTK3?
Oh, I'm sure. I haven't. I think Teams and all that jazz comes either through Mesh, which is again like the higher level API for, or some sort of Azure integration. Obviously, that should be a feature. If it's not, then WTF. But yeah, it's a good point. Thank you. I see someone posted that Vuforia is another one to do marker recognition. Yep, it is, but to do object recognition. But from my recollection, the objects have to be pretty simple.
Okay, excellent. Now, Jerome, did you have anything you wanted to go over in overtime? As we're well into overtime by now through Q&A.
Yeah, I know, but we had time, right? So
yeah.
Let's go.
I'll sign off slowly because sometimes someone might be typing Q&A now, but unless an answer or a question comes in here, I'd just like to thank you all for joining us throughout the year, and especially for today's session, of course. Big thank you to Jerome, Vanessa, and of course Ben. Hopefully we'll see you again next year, Ben, if you're ever listening. Thank you to all our organizers as well. Keep an eye out containing email with links to resources mentioned in today's talk. Please check out the forums as well to check out the slides. One more reminder to please fill out our live survey when you get a chance. Pop in the link in the chat one more time before everybody leaves here. And yeah, we'll see you next year for our next session for the Road to the Metaverse Creator Series. Happy holidays, everybody. And yeah, we'll catch up next time.
Thank you, Drew. Happy holidays, everyone.
Thank
see
you
you in
so
the
much.
new year.